Want to have a look at hybridization of oxygen in water molecule. So we have oxygen. Now the structure of water molecule is O with two hydrogens attached. And then there are two lone pairs on top of the oxygen. So what you need to understand is that the lone pairs are also in orbitals. So we need to account for their position in the molecule. So we need to get four hybrid orbitals. Four hybrid orbitals. Now, the configuration of oxygen with atomic number 8 is 1s2, 2s2, 2px, we have 2py, and 2pz. And first, each will have 1, 1, and we still have one left, and so the 2s is going to have 2 electrons. So when we draw the spin, we'll have opposite spin in 2s. Now the 2p orbital is degenerate. And so we have two spins in 2px, one spin in py, and one in pz. Alright, so what we need is to get four hybrid orbitals. So basically what we are doing here is we have this, if this is the energy profile, we have the s orbital, that is a 2s orbital with 2 electrons in there, and then we have the p orbitals at a higher energy. The first one having paired electrons, then the other p orbitals, this is px, py, then pz. The other ones having unpaired electrons. So what the hybridization basically does is that it gives us a new set of orbital, which we are calling hybrid orbitals. And it's going to be a combination of the two s orbital. So this is the s orbital, and then the p orbitals. So in order to account for this structure, we need to combine these two, and you observe that the hybrid orbital is going to be of a lower energy than the p orbital and a little bit above the s orbital. So, and it is all going to have the same energy. So the first two orbitals have paired electrons, and then we have two unpaired electrons. So this orbital is neither p orbital or s orbital, rather it is an sp3 orbital. What that simply means is that we are combining one s orbital with three p orbitals to give us this new orbital. So the same thing we did here will be used to account for the structure of oxygen. Now all sp3 hybrid orbitals have a particular geometry. With that geometry, we can predict what the shape of the molecule will look like. So for sp3 hybridized orbital, we should be expecting a geometry of tetrahedral. But then, in the case of water molecule, we have the oxygen at the center, and then we have these four new orbitals, which of course will take on the geometry of tetrahedral. Now you look at for what electrons we have in the hybrid orbitals. So in two of the orbitals we have paired electrons. And then these two have unpaired electrons. So this is an unpaired electron. Now this oxygen is combining with hydrogen to give us water molecule. So hydrogen has only one electron, that means it has only s orbital. So if we have this s orbital of hydrogen with one electron, so let's say this is the first hydrogen, hydrogen 1, and then hydrogen 2 with one electron. So this is an s orbital which is spherical. It's not going to combine with the hybrid orbitals of oxygen, contributing its one electron to form the bond. So what we have here is oxygen bonded to hydrogen and hydrogen, and yet we have two orbitals with a pair of electron each. So what is going to happen is there's going to be a repulsion between the unpaired electron, that is this and this, in the hybrid orbital, and a bonded pair electron between hydrogen and oxygen. So there's going to be a pushing away of this bond. Now we know that a regular tetrahedral geometry will have a bond angle of 109.5. So for a tetrahedral geometry, we have a bond angle of 109.5. But in the case of water, because these electrons are repairing this bonded pair, it is going to give us a kind of V shape, as you can see here. So water will have hydrogen, hydrogen. Instead of a regular tetrahedral geometry, it is given as a V shape. So that is how the hybridization of oxygen is being distorted due to the presence of the lone pairs. So there's a slight change in the geometry and it has a shape of V. So we say it is a V shape molecule. I hope this video helps you in your preparation for your examination. Watch out for the next tutorial.